Welcome to a journey through the cosmos. Today, we're unraveling the mysteries of space-time. This isn't your everyday adventure, folks. We're stepping beyond the confines of our earthly existence, reaching out into the vast expanse of the universe. As we embark on this celestial journey, we'll be exploring the enigmatic fabric of space-time, a concept that has fascinated and puzzled humanity for centuries. It's a concept so profound and complex that it has given rise to some of the most mind-bending theories about the nature of our universe. We'll be delving into the intricacies of gravity, the curvature of space, the mysteries of black holes, the concept of relativity, and so much more. Each fact we uncover will serve as a stepping stone, leading us deeper into the heart of the cosmos. So stick around for a journey that promises to be as enlightening as it is exciting. Prepare to have your understanding of the universe expanded and your mind blown. We guarantee that by the end of this journey, you'll be looking at the stars in a whole new light. So, without further ado, let's dive into the mysteries of space-time. Have you ever pondered the mystery of the universe's fabric? It's an enigma that has fascinated humans from the dawn of civilization. The more we discover, the more questions arise, fueling an endless cycle of inquiry and discovery. Let's start at the beginning. Space and time, they are not merely separate entities, but rather interconnected components, a four-dimensional framework known as space-time. The concept of space-time isn't just a mere mathematical construct, but the very foundation of our understanding of the cosmos. It's a quilt of unseen threads, woven together by the loom of the universe that forms the cosmic tapestry we call reality. In this grand tapestry, monumental events like the birth and death of stars are mere stitches, each contributing to the overall pattern. It's an intricate design, a blend of order and chaos that continues to evolve and change over eons. Today, we delve into the enthralling realm of space-time, exploring 10 fascinating facts that will surely pique your intellectual curiosity. From Einstein's theory of relativity to the mind-bending reality of black holes, we're about to embark on a celestial journey, exploring the deepest corners of the universe. Each fact will serve as a thread, further unraveling the enigmatic nature of space-time, revealing the beauty and the mystery of our cosmos. So fasten your seatbelts, sit back and prepare to be captivated by the magnificence of the universe as we journey together through the mysterious and awe-inspiring realm of space-time. With every fact, you'll find yourself closer to understanding the fabric of the universe. Today, we delve into the enthralling realm of space-time, exploring 10 fascinating facts that will surely pique your intellectual curiosity. Fact 1. Space-time bends. This intriguing concept comes to us from the brilliant mind of physicist Albert Einstein, one of the greatest scientific minds of the 20th century. He proposed this idea in his general theory of relativity, a landmark body of work that revolutionized our understanding of the universe. Einstein's theory introduced a radically new perception of the cosmos, suggesting that our universe isn't just an empty void, but a complex tapestry woven by the interplay between space and time. This fabric of reality, he suggested, was not flat but curved or warped by the mass and energy within it. When we say massive objects cause a distortion in space-time, what we mean is that sizable objects like stars or planets cause a significant shift in the structure of the universe around them. This is not a visual distortion, as one might see when looking through a warped piece of glass, but a physical change in the properties and behavior of space and time around the object. The effect of this distortion is what we perceive and as gravity. Gravity is not just a force pulling us down to the Earth, but a bending of space-time caused by the planet's mass. To help you visualize this, picture a bowling ball placed on a large trampoline. The bowling ball, heavy and dense, pushes down on the trampoline, causing a depression or a dip in the fabric. That bowling ball represents the sun in our solar system. The trampoline is the fabric of space-time. Now imagine smaller marbles placed on the same trampoline. They naturally roll towards the bowling ball, drawn by the depression it creates. Those marbles are like the planets in our solar system, including our Earth, caught in the sun's gravitational pull, continuously rolling around the edge of that depression. And so, the concept of space-time bending encapsulates the very essence of gravity as described by Einstein's general theory of relativity. This understanding has been and continues to be critical to the study of our universe. That's the sun in our solar system, and the planets are like marbles rolling around the edge of that depression. Fact 2. This curvature of space-time impacts how we perceive time. It may be challenging to comprehend, but the denser the mass of an object, the more it distorts the fabric of space-time around it. Think of it like a bowling ball resting on a trampoline. The weight of the ball causes the trampoline to curve downwards, and the same thing happens with space-time near a massive object. Now let's focus on the concept of time dilation, a mind-boggling aspect of our universe. What this essentially means is that the closer you are to a source of significant gravitational pull, the slower time seems to pass for you. It's like an invisible force that manipulates our perception of time. This isn't just an abstract concept. It's a tangible, observable phenomenon. For instance, consider an astronaut aboard the International Space Station. The gravitational pull is weaker up there than it is on the surface of our planet. Therefore, the clock ticks a smidgen slower for our brave astronaut than for us earthbound folks. This means that theoretically, over a long period, the astronaut would age at a slightly slower rate than people on Earth. Hence, an astronaut aboard the International Space Station, for instance, ages slightly slower than people on Earth. Fact 3. Space-time is a four-dimensional fabric. This concept is rooted in the theories of one of the most brilliant minds in human history, Albert Einstein. When we consider our daily lives, we're familiar with three dimensions. These dimensions are what we perceive as space, an arena where everything happens. It is composed of the directions up and down, left and right, forward and backward. Each direction, like arrows, points us to a different location in space. We use these dimensions to navigate the world around us, to move from point A to point B, and to place objects in relation to each other. But Einstein proposed a game-changing idea. He suggested that there's another dimension we experience constantly, yet it is invisible to our eyes, the dimension of time. Time, unlike the three spatial dimensions, does not offer the freedom to move in any direction. It advances relentlessly, incessantly. We cannot reverse or halt it. It flows only forward like a mighty river that carries everything with it. This unstoppable flow of time, coupled with the three dimensions of space, creates what is known as the space-time continuum. This concept has revolutionized our understanding of the universe and its workings. Therefore, with three dimensions representing space and the fourth encapsulating time, we move inevitably in a four-dimensional continuum. Fact 4. There's no absolute present in space-time. This concept is quite complex to grasp, but it's a fundamental aspect of the universe as presented by Albert Einstein. This means that the idea of now isn't universally consistent. Rather, it's unique to each observer. It is astounding, isn't it? Imagine two individuals located in two different parts of the galaxy. One is on planet Earth, while the other is on a remote star system light years away. Each individual's perception of now differs due to numerous variables. This includes their respective velocities, gravitational fields, and even the different paths they may have taken through space-time. What is perceived as now by one may be seen as the past or the future by another. This divergence is no mere illusion or trick of perception. It is a real and tangible distinction that arises from the very nature of space-time itself. This astonishing phenomenon is due to the relativity of simultaneity, another mind-boggling prediction of Einstein's theories. Different observers may see events happening in different orders. This can be equated to viewing a theatrical performance from different angles. The sequence of events changes depending on where you sit. This is a powerful testament to the dramatic, profound, and unpredictable character of Einstein's understanding of the universe. In conclusion, the recognition that there's no absolute present in space-time is a compelling testament to the groundbreaking work of Einstein. Different observers may see events happening in different orders. This is due to the relativity of simultaneity, another mind-boggling prediction of Einstein's theories. Fact 5. Black holes are extreme distortions of space-time. They are fascinating, perplexing, and among the most enigmatic phenomena in the cosmos. A black hole is an extraordinary marvel that challenges our everyday understanding of physics and the universe as a whole. When we delve deeper into the subject, it becomes more intriguing. A black hole is formed by the remnants of a massive star which has exhausted all its nuclear fuel. This star, once vibrant and full of life, now collapses under its own immense gravity, resulting in an entity so dense it bends the fabric of space and time around it. This overwhelming gravity, an almost unimaginable force, causes the star to shrink, creating a point of singularity. This is the very heart of a black hole, a place where an object's mass is condensed into zero volume. The amount of gravity it exerts is immense, causing an extreme curvature in the space-time around it. This distortion is so intense that it creates a boundary, known as the event horizon, beyond which nothing, absolutely nothing, not even particles of light, which are the fastest entities known to mankind, can escape. This creates a one-way passage, a kind of cosmic trapdoor from which not a single particle can emerge. This unyielding force and the resulting distortion is one of the reasons why black holes have continued to baffle and intrigue scientists since they were first proposed. Their existence challenges our basic understanding of the universe and continues to be a hot topic in astrophysics. Even though these mysterious entities are relatively common in the cosmos, each discovery of a black hole leads to more questions than answers, further fanning our curiosity. So when a massive star collapses under its gravity, it can create a black hole, a point in space-time where the curvature is so intense that nothing, not even light, can escape. Fact 6. Wormholes, theoretically, are shortcuts through space-time. These celestial anomalies, conjured from the depths of Einstein's general relativity, have been a source of fascination and intrigue for scientists, astronomers, and sci-fi enthusiasts alike. Imagine an intricate web of tunnels, not unlike an anthill, that cuts across the vast expanses of the universe, bringing the most distant galaxies and stars within a stone's throw. These theoretical tunnels, called wormholes, are said to exist within the fabric of our universe, opening up possibilities for interstellar, even intergalactic travel. The concept itself is an extraordinary feat of human imagination. We envisage these wormholes as shortcuts, allowing us to bypass the otherwise time-consuming journey through ordinary space. It's a tantalizing prospect to leapfrog across the cosmos in the blink of an eye. Yet despite the wonders they promise, the existence of wormholes remains unproven, a hot topic of discussion and a subject of ongoing scientific debate. Fact 7. Gravitational waves ripple through the fabric of space-time. This is a fundamental truth that is as enchanting as it is complex, capturing the essence of the universe's infinitely beautiful intricacy. Consider the vastness of the cosmos, filled with billions upon billions of celestial bodies, all constantly moving, continuously interacting, and endlessly shaping the dimensions we inhabit. Now imagine massive objects such as neutron stars or black holes accelerating or altering their trajectory in this vast cosmic playground. These celestial giants do not simply move without consequence. Their actions, much like a stone thrown into a serene pond, create ripples in the fabric of space-time. These ripples, these perturbations, are what we term gravitational waves. They are a cosmic ballet, a space-time symphony, speaking volumes about the universe's dynamic nature. In the grand cosmic theatre, these waves play a crucial role. Their existence stems from the very fabric of the cosmos, a fabric which is continuously being molded and shaped by the celestial bodies inhabiting it. These waves tell us that the universe is not static, but rather it is a constantly moving tapestry filled with motions and actions that have far-reaching effects. In 2016, scientists first detected these waves, confirming another prediction of Einstein's theory. This marked a significant milestone in our understanding of the universe, engraving Einstein's name deeper into the annals of scientific history. It was an affirmation of the dynamic, ever-changing nature of the universe we live in, and an encouragement to continue probing the depths of the cosmos. Indeed, each discovery we make, every fact we uncover, serves as a reminder that we still have so much more to understand. Fact 8. Space-time may be quantized. In the world of theoretical physics, there exist a myriad of fascinating hypotheses. One such conjecture is the idea that our understanding of space-time need to be fundamentally redefined. Conceptually, when we think about space, we typically envision it as a continuum, a boundless three-dimensional extent in which objects and events occur and have relative position and direction. But what if this isn't the case at the smallest scales? This question ushers in the theory that space-time might actually be divided into miniature, indivisible units. To visualize this, one could imagine pixels on a digital screen. Each pixel represents a distinct individual unit. You can't have half a pixel or a quarter of a pixel. Each one is discrete and complete unto itself. This distinct perspective brings forth a whole new conceptual framework, namely quantum gravity. Quantum gravity is not just a buzzword among the scientific community, it's an ambitious attempt to reconcile two of the most powerful theories in physics, quantum mechanics and general relativity. The goal is to unify them into a single, coherent theoretical framework that can explain the universe on both the smallest and largest scales. This concept forms the basis for quantum gravity, an attempt to reconcile quantum mechanics with general relativity. Fact 9. The expansion of the universe stretches space-time. This concept is entrenched in the field of cosmology, the scientific study of the universe and its constituents. As celestial bodies such as galaxies move apart, they aren't merely traveling through an already existing space. Instead, imagine the universe as a balloon being inflated. Just as the surface of the balloon expands is inflated, so does the fabric of the universe itself. The universality of this expansion is a crucial aspect to grasp. Galaxies aren't simply propelling themselves outwards from a central point. Instead, every region of the universe is spreading out, expanding in all directions. This expansion is happening everywhere at once, leading to the elusive and hard-to-grasp idea of an infinite universe. This concept of universal expansion is the core idea behind the Big Bang theory, one of the most widely accepted explanations of the creation of our universe. This theory postulates that the universe started as an infinitesimally small, dense and hot singularity. From this point of singularity, it has been expanding ever since. This continual expansion is the reason why we observe galaxies moving further apart. The further away a galaxy, the faster it seems to move away from us, a phenomenon known as Hubble's law. The mysteries of the universe are far from fully understood, and the expansion of space-time is merely a part of the grand cosmic puzzle. But for now, what we do know is that as galaxies move apart, the fabric of space-time itself expands. This is the core idea behind the Big Bang theory, which postulates that the universe started as a singularity and has been expanding ever since. Finally, fact 10. Space-time might not be the end of the story. The fabric of our reality, as we understand it, is woven from the threads of 3 dimensions of space and 1 of time, creating a 4-dimensional tapestry that encompasses everything we see and experience. These dimensions, however, may not paint the complete portrait. There is an exciting proposition put forth by some of the most brilliant minds in the realm of theoretical physics: the existence of additional dimensions. This fascinating concept is the cornerstone of string theory, one of the most intriguing and ambitious models of physical reality that we have. String theory challenges our conventional understanding of the universe. Instead of viewing particles as zero-dimensional points, it envisions them as one-dimensional strings vibrating in a multi-dimensional universe. Remarkably, string theory requires there to be 10 dimensions of space-time. This means that there are 7 more dimensions than what we can currently detect or perceive through our senses or with our most sophisticated scientific instruments. These additional dimensions, according to string theory, are not readily perceivable because they are compactified or curled up at very small scales beyond the limits of our current experimental resolution. Despite being out of sight and beyond our current understanding, the existence of these hidden dimensions could provide answers to some of the most enduring mysteries of the universe, such as the true nature of gravity, the unification of quantum mechanics and general relativity, and the origins of the universe itself. String theory, for example, requires the existence of 10 space-time dimensions, 7 more than we can currently perceive. In essence, space-time is a 4-dimensional fabric that bends under the gravitational force of massive celestial bodies, influencing the flow of time and orchestrating the cosmic ballet. It operates as the cosmic stage where the grand dance of celestial objects plays out, swirling with black holes and potential wormholes that serve as tunnels through space-time, connecting various distant regions of the cosmos. Furthermore, it is dotted with the ripples of gravitational waves that propagate across the universe like ripples in a pond, distorting space and time in their wake. Space-time is a dynamic, ever-evolving entity that stretches and expands with the universe, mirroring its constant change and growth. It is hypothesized that at the smallest quantum scales, space-time could be quantized, broken down into discrete, indivisible units. This concept, if proved, could revolutionize our understanding of the universe. Additionally, it is speculated that space-time might even hold secrets to extra dimensions, dimensions beyond our conventional understanding of three-dimensional space and one-dimensional time. These extra dimensions could provide explanations for many enigmas of the universe that are still unsolved. The mysteries of space-time continue to challenge and inspire us, reminding us of the vastness of our universe and the limitless potential of human curiosity. As we venture further into the riddle of space-time, we realize that our journey is still in its opening stages. Each new development helps us inch closer to understanding the cosmos and our position within it. We invite you, our fellow explorers, to join us on this captivating exploration. We welcome you to express your thought about space-time in the comments. Your feedback enriches our community and promotes a thirst for knowledge. Do remember to subscribe to our channel and hit the bell icon to stay on our content related to the cosmos. Share this video with those who would love this cosmic expedition. Together we can unravel the infinite secrets of space-time. Let's persistent in our exploration and admiration of the universe. After all, it's not just space-time, that's our comprehension of it is too. Keep the spirit of inquiry alive, continue the exploration.